and pen ready. Today we are going to learn about the disposable of plastics. In the yesterday's session, we learned about how to make polythene from ethene, right? Now we are going to learn about how to dispose these polyalkene plastics. Please turn on your video. The plastics, they are widely used in many aspects of everyday life, but a large scale use of polyalkene, it has created environmental problems when we come to dispose them. During their life, one of the most useful properties of polyalkene is their lack of reactivity. As polyalkenes are effectively huge alkane molecules. Okay, huge means if you remember the value of N range from 10,000 to more. Okay, so they are resistant to chemical attack. So they can take hundreds of years to decompose when dumped in landfill sites, and it takes up valuable space. They are also non-biodegradable, not degraded by microorganisms. Therefore, throwing away polyalkenes, it creates rubbish that will pollute the environment for centuries. So it is very harmful for polyalkenes. So how to dispose them? Here you can see it is a beach which is littered with polyalkene plastic waste. Okay, because they are non-biodegradable, so they are not degraded easily. So we'll look the ways how to solve this problem. First of all, copy this slide. Hello Alicia, welcome to the session. Am I audible to you?
Hello, yes, ma'am.
Okay, so in today's class, we are learning about the disposable of polyalkene plastics, how to dispose them. Okay, they are non-biodegradable. They take lots of space in the landfill slides, and if we throw them, it creates rubbish that will pollute the environment for centuries. So we'll look at the ways how to solve this problem. First of all, copy this slide.
I'm also done.
Okay, so see this figure, it is a beach which is littered with polyalkene, that means plastic waste. So it takes a lot of space and it is also non-biodegradable, polluting the environment. If we burn them, then what happens? One solution is burning plastic waste. So one way to solve this problem would be to burn polyalkenes and use the energy released to generate electricity. But if hydrocarbons burn in excess oxygen, their products are carbon dioxide and water, similar to the combustion reaction. But this solution would not help combat global warming but would help to conserve our supplies of fossil fuels that currently generate most of our electricity. So there is one advantage and one disadvantage. But here we have seen that toxic carbon monoxide gas is produced from the incomplete combustion of hydrocarbons. So some plastic waste also produces your toxic gas, that is carbon monoxide. But yes, if you burn them and if you use the energy to generate electricity, then in that way it would be helpful. But what is the disadvantage? Disadvantage is that it would not help combat global warming because CO2 is also a greenhouse gas. Okay. And incomplete combustion of hydrocarbons, it also releases carbon monoxide, which is a toxic gas.
I'm done.
So another problem is the difficulty recycling companies have in separating your plastic waste from the polyalkenes. This happens when objects have just been thrown away and not been sorted according to their recycling code. Also, if polychloroethene waste is burned, acidic hydrogen chloride gas from polychloroethene HCl gas will be given off, as well as some toxic compounds which are known as dioxins. Acidic gases, it should be neutralized before releasing the waste gases into the atmosphere, and very high temperatures should be used in incinerators to break down any toxins. So these are all the problems of your polyalkenes. Write it down. Incinerators is a machine or device which is used to burn your waste materials at high temperatures.
I'm done.
Okay, now reducing the repeat unit of an addition polymer for given monomers. How to reduce the repeat unit? So if you are given a monomer with a carbon double bond carbon, so you have to simply turn the double bond into a single bond and show the bonds either side of the two carbon atoms that would continue the chain. So if it is given, the monomer is given, so after addition polymerization, you have to make it like this. The N comes here after the bracket, outside the brackets, and the double bond is converted into single bond. So by this method, you can reduce the repeat unit of an addition polymer if you are given the monomer in the question.
I'm done.
Okay. So how to identify the monomers? How to identify the monomers present in a given section of an addition polymer molecule. So if it is given, part of addition polymer is given. So first of all, you should split the polymer chain into its repeat units. So seeing this part of addition polymer, you can easily see the repeat unit starts from this, okay, and ends here. Then it is repeating again and again. So with an addition polymer, you then need to put the carbon-carbon double bond back into the monomer. So how to make the monomer of this? If you are given the part of addition polymer, first of all, you have to make the repeat unit, and after from repeat unit, you can easily make the monomer. How? By placing a double bond, removing the brackets, and putting N outside the brackets in the front of the molecule. So both you should know how to identify monomer from the part if you are given the part of addition polymer, and how to identify the repeat unit from a monomer.
I'm done.
Okay, so this is your homework question for today. Tetrafluoroethene C2F4. It is a monomer for the polymer PTFE, which is used in non-stick coating on pans. So state what a PTFE stands for. Give the name of the type of reaction used to form PTFE. Write a chemical equation to show the formation of PTFE from C2F4. And draw the structure of repeat unit. How could polyalkene waste be used to conserve fossil fuel? PTFE means polytetrafluoroethene.
I'm done.
So the chapter is completed, hydrocarbons. So let's summarize the chapter. Alkanes, we have studied two things here, alkanes and alkenes and their chemical reactions. So alkanes are saturated hydrocarbons. Their general formula is CnH2n plus 2. About their reactivity, they are generally unreactive. Why they are unreactive? Because they are non-polar. Most reagents are polar and do not usually react with non-polar molecules. Now they are widely used as fuels. When they burn completely, they produce carbon dioxide and water. But in incomplete combustion, they produce toxic carbon monoxide gas in a limited supply of oxygen, example in a car engine. Cracking, what is cracking? Cracking means to break basically the longer chain alkanes into shorter chain alkanes. So cracking of the less useful fractions, which are less.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Useful in the industry, from the fractional distillation of crude oil, produces a range of more useful alkanes. They have lower molecular mass and well as alkene. Chlorine atoms or bromine atoms. Okay, this reaction is substitution reaction by chlorine or bromine. They can substitute for hydrogen atoms in alkanes in the presence of UV light, producing halogenoalkanes. This is called a free radical substitution reaction because in this reaction radicals are formed. The Cl-Cl bond there undergoes homolytic fission in ultraviolet light. So both chlorine got one unpaired electron, that is free radical. They are very reactive. This is the initiation step. It is followed by propagation step involving a chain reaction which regenerates the halogen free radicals. So this is very important. Initiation, propagation, and termination. Then termination steps occur where two free radicals combine and we can see a bond between the two free radicals. Next, we have studied about alkenes. They are unsaturated hydrocarbons. They have one carbon-carbon double bond. In one carbon-carbon double bond, we have a sigma, and a pi bond. The general formula is CnH2n. Okay. Next, we have studied that alkenes are more reactive than alkanes because they contain a pi bond. The characteristic reactions of alkenes is addition reaction of alkenes we have studied, which occurs across the pi bond because it has higher electron density. Ethene produces ethane. How? When heated with hydrogen gas over a platinum or nickel catalyst, that is your hydrogenation reaction. Ethene produces 1,2-dibromoethane when it is reacted with bromine water. So both the bromines get attached to one carbon of the ethene. Double bond is converted into single bond. Ethene produces chloroethane when reacted with hydrogen chloride gas. At one carbon, hydrogen is attached and one carbon, chlorine is attached at room temperature. Now with steam, ethene produces ethanol when reacted with steam in the presence of concentrated H3PO4 as a catalyst. Now the mechanism of reaction of bromine with ethene is electrophilic addition. Electrophiles accept a pair of electrons from an electron-rich atom or center. In this case, the pi bond is electron-rich. Carbocation intermediate is formed after the addition of first bromine atom. Then this rapidly reacts with a bromide ion to form 1,2-dibromoethane. We have studied its mechanism in detail. Next is mild oxidation of alkenes. Then we have studied about the oxidation of alkenes. That mild oxidation of alkenes, if you do the oxidation of alkenes by cold dilute acidified KMnO4 solution, it gives a diol. But in hot concentrated acidified manganate solution, it will break the carbon-carbon bond and it gives two oxidation products. Identifying the two products formed will indicate the position of the carbon-carbon double bond in the original alkene. Then we have studied about polymerization, that alkenes produce many useful polymers by addition polymerization. For example, polythene made from CH2 double bond CH2 ethene. Polychloroethene is made from CH2 double bond CHCl. Then we have studied about the disposable of polyalkene plastic waste. So it is difficult. As much of it is chemically inert and non-biodegradable. So its disposable is difficult. When we burn them, then waste plastics may produce toxic products such as hydrogen chloride from PVC polychloroethene. So this is the summary of the chapter. We have studied this. So any doubt in this? Or should we practice some? So please do this question now. 2-methyl pentane is 3-methyl ethyl pentane and 2,3-dimethyl butane are alkanes. So for each one, give its molecular formula, structural, displayed, and skeletal formula. Give the general formula that is used to represent alkanes. Two of the alkanes in this question are isomers of each other. Identify which two and identify the type of isomerism they show. Define isomers and name the alkane whose structural formula is this. So this is a total of 18-mark question. You have to solve it, the entire question in your copy. When you are done, please let me know. What is the molecular formula of 2-methyl pentane?
C6H14.
Yes, C6H14. And for 3-ethyl pentane?
C7H16.
C7H16. And for 2,3-dimethyl butane?
C6H14.
C6H14. So molecular formula I have told you, this is the molecular formula of all these three compounds. Structural formula you can easily, if you have made the structure, so you can easily write. Displayed formula, you just have to show the bond. Skeletal formula, you have to make it like this. Okay, so you can do this question. Give the general formula that is used to represent alkanes.
CnH2n plus 2.
CnH2n plus 2. Good. Two of the alkanes in this question, they are isomers of each other. Which two, and identify the type of isomerism. And first of all, tell me what are isomers.
Same molecular formula, different structural formula.
Yes, isomers, they are compounds that have same molecular formula but different structural formula. Different structural formula. So you can see which have same molecular formula. So which two are isomers?
2-methyl pentane and 2,3-dimethyl butane.
Yes. 2-methyl pentane and 2,3-dimethyl butane, they are isomers of each other because they have same molecular formula but different structural formula. Which type of isomerism they show?
Structural.
Structural? No. We have how many types of isomerism we have studied in the
Chain.
previous chapter? Chain, functional.
Chain.
Yes. Position. These are the types of isomerism we have studied in the previous chapter. So this represents chain isomerism because one carbon is of 5 carbon atoms root chain and one compound is of 4 carbon atoms root chain. So this exhibits chain isomerism. Now name the alkane whose structural formula is this. E part.
Two, 3-dimethyl butane.
Pardon?
2,3-dimethyl butane.
Are you sure it is 2,3-dimethyl butane?
2,4.
2,4 what? Say complete.
Dimethyl butane.
Butane? Are you sure it is butane? How many carbon atoms are there in the parent chain?
Is it not 4, ma'am?
Why 4? I can see 5 carbon atoms. 1, 2, 3, 4, 5. This CH3, CH. Then this CH3 is in the branching because it is in the bracket. Then CH2, CH. Then CH3, 2. Okay, that means one CH3 comes here and one CH3 comes here. Because at this carbon only your 2 CH3 are attached. So there is only one way to write this. So it is 2,4 dimethyl pentane, not butane. Okay. Is it clear?
Yes. Yes.
This is also your homework question for today. So you have to solve it. Please write it down. Alkanes are saturated hydrocarbons. Explain the words saturated and hydrocarbon. Alkanes are generally unreactive. Why? Write balance symbol equation for complete combustion of methane and ethane.